All right, welcome to this explainer on Albert Einstein's absolute game changer of a 1905 paper on the electrodynamics of moving bodies. Today, we're going to unpack the exact step-by-step logic that completely rewired our understanding of the universe. And look, this isn't just about dusty equations, it's about fundamentally shifting how you perceive space, time, and your actual place within it all. Let's get into it. So, let's kick things off by challenging your fundamental perception of reality with a pretty simple question. What if time isn't ticking at the same rate for everyone? I mean, we just go through our days assuming a second for me is exactly a second for you, right? No matter what we're doing. But what if the very act of moving physically changes the nature of time itself? Okay, since we're dealing with some heavy physics here is our roadmap for today. 1. The illusion of absolute time. 2. The magnet and the conductor. 3. 2 radical new rules. 4. Bending space and time, and finally, 5, the cosmic speed limit. All right, starting right off with section 1, the illusion of absolute time. To ground all this abstract math, Einstein actually uses an incredibly ordinary everyday event. He points out that any mathematical description of motion is pretty much meaningless unless we agree on what time actually is. So he defines time strictly as a judgment of simultaneous events. Like, if you say, hey, that train arrives here at 7 o'clock, what you are physically saying is, the pointing of the small hand of my watch to the 7 and the arrival of the train are simultaneous events. Make sense? Well, here is the crucial point. That super simple definition totally falls apart when people are moving. Because it takes time for light to travel between points, 2 events that look simultaneous to someone standing completely still will actually not be simultaneous to someone moving past them. Einstein proved we literally cannot attach an absolute meaning to simultaneity. If you and I are moving at different speeds, our versions of now are physically, measurably different. Which brings us to section 2, the magnet and the conductor. This brilliantly illustrates a weird little flaw in classical electromagnetism that was basically driving Einstein crazy. In classical Maxwell physics, if you take a magnet and a conductor, like a wire, and move them relative to each other, you get an electric current. But classical physics treated the math totally differently depending on which piece you moved. If the magnet moves, boom, it creates an electric field. But if the conductor moves while the magnet just sits there, no electric field. Instead, an electromotive force magically does the exact same job, creating the exact same electric current. Einstein looked at this and realized this physical asymmetry was just an illusion. Nature absolutely does not care who is truly moving. The observable result depends only on the relative motion between the two objects, meaning the concept of absolute rest simply does not exist anywhere in the universe. You're only ever moving relative to something else. And that massive realization leads perfectly into section 3, 2 radical new rules. To fix this giant hole in physics, Einstein introduces 2 clean, incredibly bold rules. First up, the principle of relativity. The laws of physics are exactly the same for everyone moving steadily. Second, the constancy of the velocity of light. This just means light always travels through empty space at the exact same velocity, c, no matter how fast the thing emitting it is moving. So if you shine a flashlight from the front of a speeding train, the light doesn't travel at the speed of light plus the speed of the train, it just travels at the speed of light, period. By just accepting those 2 rules, Einstein made a huge leap. At the time, all the top scientists believed empty space was filled with this invisible background stuff called the luminiferous ether that light supposedly waved through. Einstein basically said, yeah, we don't need that. He mathematically proved the ether is completely superfluous. We don't need absolute space. We just need relative motion and a constant speed of light. Okay, section 4, bending space and time. This is where things get really wild. Think about it. If the speed of light is constant for absolutely everyone, something else has to give. And what gives is space itself. Einstein's equations prove that an object that's a perfect, rigid sphere when it's at rest literally shrivels into a squished, flattened shape, an ellipsoid of revolution, when viewed by a stationary observer while it moves at high speeds. Space literally contracts in the direction of motion. And it's not just physical space that shrinks, you guys, it's time, too. In the paper, he concludes that if you take 2 synchronized clocks, leave one alone, move the other one around, and then bring it back, the moving clock mathematically ticks slower. It literally lags behind the stationary one. That is time dilation. The faster you move through space, the slower you move through time. Now, to prove this wasn't just some math gymnastics, Einstein offered a real-world thought experiment. Because the Earth is a spinning globe, the equator is moving much faster through space than the poles. So he concluded that a balance clock sitting at the equator must actually run slightly slower than the exact same clock resting up at one of the poles. Time is physically stretching out based on velocity. Finally, we arrive at Section 5, the cosmic speed limit, the grand finale of this relative universe. Usually, if you're running at 10 miles an hour on a train that's moving at 50 miles an hour, your total speed as someone standing on the ground is 60 miles an hour, right? You just add them up. But Einstein's new equations prove that velocities do not just add up cleanly at high speeds. Because space is shrinking and time is slowing down, the math dictates that combining two speeds will never, ever allow the resulting velocity to exceed the speed of light. And here's exactly why. When he looked at the dynamics of an accelerated electron, he saw that kinetic energy behaves incredibly strangely. At low velocities, totally normal. But as you start approaching the speed of light, the kinetic energy required just starts spiking exponentially. As you get closer to c, the kinetic energy you'd need to go any faster approaches actual infinity, meaning you would need infinite energy to push a mass to the speed of light. So the huge takeaway here is that c isn't just a really fast speed. It physically acts as an infinitely great boundary. It is the fundamental speed limit of the universe that no mass can ever cross. It literally dictates the structural reality of the cosmos. I want to leave you with this final thought. Einstein showed us there is no absolute rest, no universal clock ticking away in the background for everyone. If this explainer has shown you anything, it's that space and time are entirely relative to your own motion. So, what does your current reality actually look like to the rest of the moving universe? Your now is yours and yours alone. Keep thinking about that, and we'll see you next time.